everybody in this room knows what physicians do. They repair and maintain our bodies according to established medical practice. But what is it that I do as a scientist? Okay. Now, the answer to that question really depends on how we define the word scientist, science, scientific method. And as you saw in the teaser, there really is no consensus, there's no agreement as to what any of those words mean. Now, that hasn't stopped us from developing a very different view of reality than what came before modern science. But some areas have struggled, and particularly I want to talk about what I do, which is deep time science, Earth and planetary science, looking at very long time scales, millions, billions of years. Now, the problem is...
Sorry, Mark, can you use the mic, if you don't mind? We are recording.
My voice could fill a lecture room with 700 people without a microphone.
Yeah, recording.
Okay, this is going to work? Good. Okay, the problem is that when we go to try and define science, we make a whole bunch of mistakes. Okay? We either rely too much on experimentalism, okay, which is part but not all of science, as in the Wikipedia entry here for scientific method. You can read this faster than I can speak. Or we simply descend into nebulous platitudes like the UK Science Council definition of science here, which actually, if you look at how the do-your-own-research conspiracy theorists describe what they do, this is eerily similar. Now, presumably knowing the pitfalls of even attempting to do this, you might be interested to know that august bodies that ostensibly represent our interests just refuse to even try the exercise. For example, it's curious that in its 162-year history, the U.S. National Academy of Science has never, in fact, defined the term. Okay? Now, as I said, this really hasn't stopped us from having a very different view of the world, what came before. But, for example, what I do and what deep time scientists, Earth and planetary scientists do, is not well defined by what Wikipedia says science is. For example, I make observations in the field, I pick up samples, take them to the lab, undertake geochemical analysis, and if I'm lucky, I'm going to be able to put together a self-consistent narrative that's compatible with the preponderance of evidence, if the geological record cooperates. Right? It may be that there are vast periods of time that aren't represented in that record. What I can't do is run Earth history back and forth half a dozen times to get good statistics. Okay? So the question then is what I do science? Now, I think every physical scientist, if you push them, they would agree to a statement like this. We can't prove anything to true, we can only falsify hypothesis. But the problem is, with deep time studies, we can't hypothesis test in the way that I think the average person on the street would understand that. Okay? So, is that scientific? No shortage of people will say, no, absolutely not. Okay, famously, this guy here, Karl Popper, says, look, historical sciences, and by that he meant biological evolution, geology, deep planetary time science, they take universal laws for granted. Okay, so they're simply metaphysical research programs. That's not science. Well, that doesn't sound like much of a compliment, right? But it's a giant upgrade on what he first called us, which is pseudoscience. Now, Popper is actually fallen out of favor with modern philosophers for a number of reasons, a couple mentioned here, one of which is his view that if a hypothesis makes a prediction that isn't found to be true, the hypothesis is also false. And the philosophers call this asymmetric logic, because in fact anybody that does experimental work knows that an unsuccessful test can be due to a crappily designed experiment rather than be wrong. So again, if pressed, we say true. Positive evidence is never conclusive. We could always, but negative evidence can, in fact, always guarantee the hypothesis is incorrect. Maybe even more so. Here's a quote from Potter. There can never be any reason whatsoever to believe that any scientific claim is even approximately correct. Okay, now, I suspect that we all share a belief system, right? And that is, if I were to let go of this glass of beer, that universal gravitation would in fact, be active. Okay? So, the problem with, I say modern philosophers with Hubbard, nicely summed up by the late Peter Lipton here, is it's remarkable that the philosopher who holds such an extreme skeptical view of science is actually the leading candidate for the scientist philosopher of science. So in fact, even though philosophers have fallen out of love with this guy, for the most part, physical scientists still can falsify a hypothesis and so on. Now, some people take even more extreme views. Here's Henry G., paleontologist, who said, historical conclusions can never be tested by experiment. Fair enough. Okay? And so they are not scientific. No science can ever be historical. Well, that's a pretty strong statement. And you'd think somebody that's going to make a statement like that would, in a 300-page book, define science. And the fact that he didn't suggests to me that he's devoted to that Wikipedia definition of the scientific method, which is very narrow. Now, of course, there are people with other viewpoints argue that historical sciences on a co-equal epistemic footing to experimental sciences. They're different, but due to something that's called the asymmetry of overdetermination, which in my view is a fancy way of saying that it would be easier to tell if the Yellowstone supervolcano erupted yesterday than it would be to predict if it's going to erupt tomorrow. Fair enough. Stan Shum, a lovely little book called To Understand Earth, 10 Ways to Be Wrong, says, of course there's no such thing as the scientific method. But there's a scientific approach. And that is an absence of bias, intellectual honesty, an avoidance of metaphysics within a systematic investigative framework. And hard to believe anybody in this room thinks that that's a bad idea. Okay? And that as long as we conduct ourselves in this way, we'll be doing good science. But the thing that you might have been struck with, as I was when I first read that, is, isn't this exactly how you want your auto mechanic or your physician or the judge in your trial to conduct their professional life? This is nothing specific about science. This is really about how we would want any human intellectual activity to be undertaken in an ethical fashion. I mentioned Adrian Curry here, interesting young philosopher of science, who broadened my mind in this regard, because his historical science actually is as much about what is possible than what happened. And those of you, as modelers in the audience, I think there's at least one, this should come as some sustenance to the soul. He says, look, we get to the actual by situating our data within possibilities. So in fact, undertaking a fully scaled, credible physical model that accounts for all physical laws, even if it doesn't replicate what we can see around us. It doesn't mean that there isn't a planetary system somewhere for which this isn't relevant. Anywho, let's in fact acknowledge that philosophy isn't going to really get us to where we're going. Okay? I mean, I've come to see in my readings, it's a 2,500-year exercise in he said, she said, although obviously mostly he said. So it's nice to see philosophers like Carol Cleland, I just mentioned, making a mark in this. But instead, let's do this. Let's go back, let's take a trip through the last, nearly 100 years, and just probe for possible weaknesses how we approach what we're doing. Okay, so circa 1930, what were the most distinguished and influential scientists of the time, Earth and planetary scientists, thinking about their problems? Well, these two folks here were absolutely convinced, certain, that continents couldn't possibly move relative to one another. Okay? This chap here, we'll talk a bit more about him later, he says that the planet we're standing on, the mass was ripped out of the sun when a rogue star happened by. And he probably thought this was a billion years ago or so. This chap here, very distinguished, he said that all orogeny, orogeny, mountain building, making basins, like in fact the one we're standing on now, the Great Kanto Basin, or the mountains in northern Honshu, that they formed because the Earth is continually expanding and contracting. Okay? Now, of course, these views now seem comical to us, but they have something in common. That is, there was absolutely, positively not a single scrap of observational evidence that required any of them to be true. Right? Now, what happened subsequently, it was recognized that, the nebular hypothesis of formation of our solar system, which was thought to be suspect back when Clerk Maxwell was studying the rings of Saturn, and he recognized, there's not enough mass in the solar system to collapse into this disk. And he said, well, but wait a minute, what if there was 100 times more mass in the form of hydrogen and helium? Then this would work. So all of a sudden, we don't need a rogue star. We can simply go back to the long-standing Kant-Laplace hypothesis from several hundred years ago. Interestingly, though, this anti-mobilist, this idea that continents can't possibly move, and boy, you read these papers, and they are subtle about it. Now, this is lunacy to them. But this idea of the oscillating Earth, expanding and contracting, or even say the fixed continents, they persisted right up into the 1960s. Now, I'm ashamed to say my institution was a hotbed of this kind of, what looks now like quackery, but again, was the most distinguished scientists of the time. Okay, now let's fast forward to 1960. As it happens, this is the year that I took my first elementary school science class. What were the greatest minds of the time thinking? Well, this guy here, he thought that when sedimentary basins, like the Kanto Basin we're standing on, when they got between 3 and 12 kilometers thickness, they spontaneously erupted into a mountain chain. Okay? This guy here didn't think granites were igneous rocks. This guy here, Nobel Prize winner, thought that the moon is an undifferentiated object of the same composition as the sun minus a lot of hydrogen. Okay? And this guy, despite leading the institution that was going to confirm plate tectonics, believed right up into the 1960s that the ocean floor, okay, was primordial. It was the oldest rocks on the planet. Well, again, what these views held in common is there was absolutely, positively, not a single scarab of empirical evidence that required any of them to be true. And yet, these were the paradigms, okay, of the time. Okay. Well, again, what happens? Plate tectonics. Despite the efforts of the director of the Levant Observatory, plate tectonics becomes self-evident. Why? Did somebody write a proposal or turn an envelope over and say the planet must work by plate tectonics? No, what happened is we were in an existential fight with the Soviet Union, and we didn't want our submarines to bump into seamounts. So the Department of Defense provided lots of money to science organizations to map the seafloor, and what we found, in fact, was the evidence that led to the foundation of plate tectonics. So serendipity in my business has actually led to the most the zeroth order discoveries over the past century. plus. The other thing was the return of the moon rocks. Because, in fact, Harold Urey was such a dominant intellectual figure. He simply absolutely overwhelmed anybody that said that the moon wasn't this undifferentiated, cold object. But then it's pretty clear as soon as these rocks get back from the Apollo missions that the moon had completely melted upon formation, and it actually let the horse out of the corral in a big way, because the intellectual climate was so suppressed because of Urey's dominance that the group went to the opposite extreme. Everything's melted. The moon melted. We melted. There was no stable crust. There was no life. There was no water on Earth for 1 billion years. Okay. Yeah, and I say Apollo rocks, moons melted on formation, and 50 years later, we don't think much different. Okay, now let's fast forward to 2005 and ask what the biggest ideas were in Earth-Moon evolution at the time. Well, Robin, in fact, had just published her Mars-size impact or origin of the moon. You've all heard of this, okay? Where, say, an object that's roughly the size, mass of Mars, smacks in, glancing blow on Earth, and spins the moon off, and there you go. Alessandro here, in fact, come up with an explanation for what's called a late heavy bombardment, and I'm going to give you some more details on that in a sec. But it was, in fact, a result of the return of the Apollo samples that scientists saw evidence, or they thought evidence, that in fact there had been an anomalous period of bombardment in the inner solar system at 3.9 billion years. GA, by the way, that means giga-anon billions of years. And he, in fact, I'm going to show you this, he came up with a model that, in fact, gave it a mechanism because it was curious. Why would after 600 million years after solar system formation, 4.5 billion years ago, why would all of a sudden there be all this rogue material to bombard? You look up at the moon. I mean, it's beaten up, right? And you think it's beaten up? With our gravitational cross-section, we would have got beaten up 25 times worse. Okay? So it was thought, if there was life, it would have been sterilized by this. It was a hell of a time. Truly a hellscape. Okay, so again, here's the Theia hypothesis. Mars-sized object smacks into proto-Earth. Boom, Earth and Moon. I'll show you no more later. Now, the late heavy bombardment, a little more complicated. Okay, we brought back samples, Apollo 14, Apollo 17, which were thought at the time, and reasonably so, that Apollo 14 would in fact give us the age of this big crater here, Imbrium, and Apollo 17 would tell us how old Serenitatis was, these two big basins here. And you see they're big, okay? Hundreds or even 1,000 kilometers in size. And we thought that we dated them pretty well back then. Okay? And here was the view, which is that if you looked at argon 4039 dates, you almost certainly haven't heard of that. It's basically potassium argon. Potassium 40 decays to argon 40. Everybody take a deep breath in. Okay, ready? Come on. Humor me. Okay, 1% of what you just breathed was argon 40. And why is that? It's more abundant. Well, tonight it's probably more abundant than water vapor. Okay? Except for nitrogen and oxygen. Because the Earth is old, because there's a fair bit of potassium, and potassium decays to argon. So we can use this to date these rocks. And when we did, whoa, we got this big spike of ages at about 3.9 billion years. And whoa, something dramatic happened. And Alessandro, in fact, there were competing hypotheses. Let's have a look. Here's the Earth formation, solar Earth-Moon formation, 4.5 billion years. So the one idea was that there was a logarithm, because this is the log scale. There was an exponential drop as the solar system cleaned itself up. A lot of junk around there, right? After planets formed, there's still some space junk. It takes a couple of billion or a couple of 100 million years to clean up. Maybe there was a bunch of cataclysms. Maybe there was a sawtooth. But this idea that there was a unique spike after the bolide or the impacts and decay, there was a big spike at 3.9. And this, in fact, if you look at the NASA literature back in the 70s, 80s, the 90s, this is seen as one of the two great triumphs scientifically of the Apollo return missions. that the idea of this late heavy bombardment. And here's Alessandro's model. Now this is interesting. You know, Jupiter, Saturn, Neptune, Uranus. Okay? What, Neptune, Uranus? Because at about 800 million years, Jupiter and Saturn come into a 1 to 2 mean motion resonance, and actually Uranus and Neptune switch orbits. Now the result was all this space junk out here, well, a fair bit of it gets thrown into the inner solar system. The moon gets whacked. You can see it's pretty ragged up there, and we get whacked 20 times worse. So what I'm going to tell you is that, you know, I'm ahead of time here, that what these views held in common was that there was absolutely, positively, no empirical evidence that required that either would be true. Now, don't get me wrong. Let me make this clear. There is nothing wrong with having an interesting new idea. Okay? That's how science proceeds. What isn't so cool is when the community at large rolls over and accepts a paradigm based on, everybody, absolutely, positively, no empirical evidence. That's going to turn out to be bad. Okay. So what's happened? What's the problems with Thea? Right from Robin's first models, it was pretty clear that, you know, you collide this Mars-sized object, it's in fact going to end up, the moon is going to end up 70% of the collider, the impactor, and the Earth's only going to get a little fraction of that. Why is that bad? Well, that is because the Earth and Moon, we are isotopic twins. Okay? By isotopes, I mean, you know, they're different elements, but those elements have different numbers of neutrons. Okay? And we can measure these things exquisitely precisely. So precisely, anybody been to the Tokyo Dome for a baseball game? When it was full, right? Here's how precisely we can measure isotope ratios. If one person were to get up out of the seat of the dome, go to the restroom, the mass of the dome of people has changed more, okay, less than our ability to measure the difference of mass of isotopes of oxygen, chromium, and molybdenum, and things like that. So we have exquisite measurement techniques now. Now here's the rub. This is a weird plot. There are 3 isotopes of oxygen. Big, 16, 17, 18. 16 is the big one. 16 is, so what we're going to do is we're going to divide this axis here will be 18 over 16 in parts per thousand, 17 over 16, a funny parameter here. And what we see is that everything in the Earth and Moon plots on this red line. Okay? Things happen on planet, they fractionate the isotopes, but they're stuck. They're just going to move up and down that red line. What about these meteorites that fall in? We're sampling outer space. We can just wait for the stuff to fall, right? There's over 70,000 meteorites been found, finds and falls. What we find is 99% of them, they're the carbonaceous chondrites plot down here. They don't look anything like us. The ordinary chondrites plot up here. There's another funny carbonaceous chondrite here. The sun plots down here. Nothing looks like us in the moon, except maybe ensign-type chondrites. Okay? This one distinctive form of ordinary chondrites of meteorite. And it plots pretty close to us, maybe not exactly, but the thing is, it isn't what Earth is made out of. Okay? So the isotopes are identical, but the major element composition, okay, is not like the Earth, not like our mantle. So it's well, let's just say, okay, what if of all these 70,000 candidates we have, maybe we got hit by an S-type chondrite that was just coincidentally within a part per million, okay? 1 part in 10 to the 6th of our isotope composition. Okay, that's consistent, but here's the problem. There's this radioactive system here. Hafnium-182 decays to tungsten-182. Okay? Hafnium is the mineral, is an element that would love to go into our mantle, our silicate mantle, our rocky mantle. Tungsten wants to go into our core. We've got a stainless steel core. Okay? Tungsten wants to go down there. The hafnium wants to stay in the mantle. And so, in fact, when we look at these meteorites, these are meteorites. These are chondrites. Okay, here we see that its isotope composition, which again we can measure exquisitely. Okay, 182 over 183. Here's where chondrites are. Here's where the Earth's mantle is. Okay. Well, it isn't just that we would have to have an object that accidentally had exactly the same isotope composition as us. And S-type chondrites are pretty good. But in fact, they would have to have had the same differentiation story. All those planetesimals, the embryos, the little building blocks of a planet, as they form cores, those planetesimals would have had the same they would have had to have had their cores separate from their silicate portion at exactly the same time that we did. So this is getting beyond plausible. Even if there was an enstitite chondrite that just happened to have a little different major element chemistry, we've got the isotopes, but now we're asking it to have had exactly the same prehistory in terms of all those little objects that went into it, for their cores to have formed at exactly the same history as ours did. So it's simply implausible. And the weird thing is, we have known this since the year that Robin's paper was published in 2004. So we've had clear evidence. I mean, I don't know, there's a bunch of different hypotheses. There's half a dozen or so ideas about how the moon actually did form. The one that I know is extremely unlikely is the one that everybody knows, the person on the street. In fact, I just as I came here, just before I left to get on the train, I asked Google AI to explain the Mars-sized impactor, and it says, well, a Mars-sized planet named Theia. And I say, bad idea to name objects that are imaginary, because that'll come back to haunt you. Okay, you guys have other sort of problems. Okay, I've mentioned this is potassium argon dating. And just to give you a little primer here, this is how the system works. It's pretty weird. Let's say that there's an object that has an age of 1. And then yesterday, 0 age, okay, it loses argon. Argon doesn't want to stay in a condensed solid, right? It's a noble gas. It wants to come out here. Why are you breathing 1% argon right now? Because the argon doesn't want to stay in those condensed solids down there. So, in fact, there's a pretty clear relationship. You see these nice curves. This is what happens if the argon is lost by diffusion, the rate limiting transport step in all solids. Okay, what do the moon rocks look like? Okay, this is what the data look like. Okay? So they're not talking about, this is the age down here where the heating occurred. What they've done is they've picked 3.9 billion years here, and they picked that single step at 3.82. Absolutely, with no physical theory in mind. Simply, if you had an age that was in this window between 3.8 and 3.9 billion, you got added to the histogram. And now it comes along, the modelers, Alessandro comes along and says, whoa, that's a signal I can model to. And so the system, it's this vicious cycle. A student and I did a calculation around the same time where they said, because the daughter product in this parent-daughter decay system is being lost by diffusion, can we use the predictability of diffusion? It is absolutely, it's thermal conduction, right? We put, I put a teaspoon in this, say it's a hot cup of coffee, right? I can predict exactly when that spoon starts to get warm in my fingers because it's the rate limiting transport. So it's simply random molecular motions being transferred. And what we found was even if, here's the LHP era, 3.8 to 3.9, even every model of ours has the monotonically decreasing impact rate, you make illusory peaks at around 3.9 billion years. So, even if the data hadn't been cherry-picked, it's still, in fact, at least plausible that, in fact, the data simply was an artifact of this curious heat transport, mass transport mechanism. Okay, and indeed, and Alessandro, who I think, felt a little betrayed by his scientific brothers over, in fact, creating what amounts to an aphysical artifact that he and his colleagues spent a long time. What they found shortly after this was that the model that had produced that nice result that I showed you earlier, of, Saturn and Jupiter with the 1-to-2 resonance, they could not reproduce that. It was some kind of numerical that the instabilities that come in these models happens within 1 million years of Earth formation. It doesn't wait 1 million years. Okay? So yeah, his prediction was people will abandon the cataclysm. Now you go to Google AI and you ask about the late heavy fire, you're going to get the same story. These you have to drive a wooden stake through the heart of these things. Okay, so why do we keep doing this? I think there's at least a couple of reasons. Okay, and the first is there's no such thing as the scientific method. We're all going to individually have to figure out that maybe we'll use Shum's scientific approach. I think that's as good a place to start as any. Would somebody using Shum's approach have cherry-picked arbitrary ages off a lunar argon-4039 spectrum? No. Okay, and the second is that we're humans. Okay? And here at TC, this is our guy, the Rogue Star guy, 135 years ago, published a paper that's still quoted today, which he said, look, we're hardly a species of causal determinists. We're basically 1 foot in the cave to feel like we understand where we came from. Okay? Whether you're some primitive society, all societies, right? Well, maybe with one exception. Okay, we got a tough job. I'm being asked to figure out things that happened 3 or 4 or 4.5 billion years ago. Okay. Okay, so that's not easy. So we don't have, well, I shouldn't say there are 4.5 billion photons, okay, that are 4.5 billion light years away, that if I could image them, I could actually see early Earth. But I don't have access to them the way astronomers do objects that are even, 13 billion light years away. I can't, as I said, I can't run Earth history back and forth half a dozen times. I'm stuck trying to I'm trying to explain things. Now we'd be great if every one of my models was purely quantitative. If I could express everything in mathematical terms, there'd be, once we start using words, you start to get fundamentalists. Like, in fact, in my business, James Hutton, the father of modern geology, said in his classic text, we can see no vestige of a beginning, no prospect of an end. And within 50 years, there was literally a group of British geologists going, no vestige of a beginning, no prospect of an end. That is, that, as Aristotle thought, the reality, the world is timeless. There was no beginning, and it will go on forever. Now, interesting, this is in the Victorian era, the 1860s, 70s, and thermodynamics is being invented. So, Lord Kelvin says, no. There is a fixed amount of energy, and when it's gone, it's gone. Now, he didn't know about radioactivity, no fusion, but we give him a rough time in our intro geology textbooks because, he was certain the Earth couldn't be more than 20 billion years old. And he got that wrong, but, he was the world's first geophysicist, and I got to give him credit for that. Can't quantify most evolutionary relationships, like, for example, a chemist could describe, chemical kinetics. And we've got a really incomplete physical record. Okay, I'll talk about this more. So I'm starting to wrap this up. Let's have just one example, and then I'll get to my soapbox and let you guys get back to drinking. Okay, let's talk about ancient plate tectonics. In my community, we've established over 50 years certain rules that we play by. And oddly enough, 2 of them are this. If we don't see evidence of a process in the rock record, the fragment and probably biased rock record, it didn't occur. If we explicitly don't see evidence of past plate tectonics, it means it wasn't operating. Okay? This is what we've done. okay? And again, questions of social order, okay? That in fact influential people set this agenda, and we've basically been following it for 50 years. But plate tectonics famously erases evidence of its existence. The ocean floor aren't the oldest rocks on the planet. They're in fact, the oldest ocean floor is just off the coast of Japan, and it's about to in fact commit ritual suicide. It's going to subduct underneath Eastern Asia. So the idea that we should expect to see, evidence of plate tectonics in the way distant past belies the fact that we can see the mechanism today is not real good at preserving that evidence. Now, my mentor and friend and Kevin Burke, late Kevin Burke, said, look, let's think of this in terms of a null hypothesis. If everyone can agree that plate tectonics is the dominant geodynamic regime on the planet today, then the null hypothesis, let's assume it was operating until we have evidence it wasn't. Well, in fact, it kind of makes sense. I mean, it's informed by absence of evidence is not evidence of absence. You've probably all heard that. You can't prove a negative. Occam's razor, Sir William of Ockham, right? That the simplest explanation is probably the most likely. Bayesian hypothesis. I'll talk about this in a second. Before I move on, I should say that it's interesting that in my, in a cosmetic reading of the philosophy of science literature, one thing comes clear is that actually none of these are epistemic truths. That the absence of evidence, of course, can be the evidence of absence. Because if nothing happened, it wouldn't leave a record. You can't prove a negative. My favorite paper on this topic is entitled, I Am Not a Giraffe. Okay, you can prove a negative. Occam's razor, the simplest, well, that's actually a pretty good rule of thumb in my world, but the biologists hate it. And why? Because evolution is putting a lot of effort into making things really complicated. So, and a Bayesian hypothesis. So basically, what this is saying is the old Reverend Bayes was like, it's okay to have a favorite hypothesis, okay? At least as as a model that you can. But in fact, what Bayesian analysis is saying is it's going to give way to more refutable models. So actually, in my view, the simplest model for the Earth's geodynamic evolution is that plate tectonics has always been operating, because actually it explains a lot. And whatever, plate tectonics itself isn't simple, but this is simpler than we having it start and stop or having unspecified mechanisms. And you don't need to know this, but in fact, arguably the paradigm, the most popular model that's around today in my world is that we didn't actually get plate tectonics until 2.5 billion years ago. And that we had Venus-like, what's called stagnant lid or single plate convection. Well, Musk may want to go to Mars. I don't want to go to Venus. The surface temperature of Venus is 500 degrees Celsius. Okay, why? Because there's no mechanism to sequester CO2. Why are we having this conversation? We're having a conversation because plate tectonics has been operating probably since the get-go. If it wasn't, there'd be no mechanism to sequester CO2. CO2 comes out of a volcano, what happens to it? Okay. Well, this rock over here that's weathering above sea level, okay, it releases calcium. The water in the atmosphere, okay, plus the CO2 makes bicarbonate. It takes that calcium, deposits it as calcite, as a clamshell or a coral reef or chemical sediment, calcium carbonate, and that material can be subducted. I say the reason why we live in this temperate world is because we have exposed continental rock above sea level. How we would want the planet, how we would lose that CO2 if plate tectonics wasn't operating for 2 billion years is hard to understand. Okay, so I'm wrapping up here. And this is a little off topic, but I think it's could stimulate a little discussion. For 60 years, the National Science Foundation of the U.S. has been polling Americans. And it depends how you ask the question, but for 60 years, half of my countrymen say that the Earth is basically 6,000 years old and formed in the fashion described in Genesis verses 1 through 9. And half don't. And that's okay, but the amazing thing is 80% people polled over 60 years say that federal investments in research and development in science, medicine, mathematics are justified. Now, what's fascinating is between April 2020 and December 2021, you're probably aware of this. Confidence in science, trust in science and science dropped dramatically. And in fact, it's fallen off a cliff as I speak to you. Well, what could explain such a shift? Well, something happened. We developed RNA-based COVID-19 vaccines. Clinical trials began 8 weeks after the first confirmed case in my country. It eventually eclipsed the record for vaccine development to FDA approval by a factor of 300%. And that was mumps way back when. And arguably kept 20 million people alive in the first year. Well, at the same time, as trust in scientists is dropping, pretty much around the globe, we've been asked to, in fact, increase our outreach to the public. Events like this. Okay? What's interesting is that public trust in science actually doesn't scale with their understanding of science. It actually scales exactly with their trust in scientists. Okay? So in fact, as we've been putting more effort into reaching out to the public, I'm not saying that this is causal. I'm saying that at the same time, public trust is cratering. Wonder why? Well, is it possible that that lack of common definition of science among us practitioners and our ability to communicate, is that part of the problem? Okay, I've got a believer back there. Thank you. Okay. Every time during the pandemic that I heard follow the science, I grimaced.
Awful.
Follow the science, follow the science, follow the science. What does that mean? Remember, there is no definition of the science. But I'll show you this. Here we are in March and April 2020. We're just getting underway. Here are the Italians now. Of course, you remember they got hit early, got hit hard. And they're reasonably using, standard ethnological models, and they're saying, okay, well, the cases are going to go like this. Here is the infamous Ferguson et al., March 16th. This is why Britain shut down. Okay. It looked at 3 months from now, 3 million Americans and Brits are going to be dead. Okay. Now, my question to you is this science? Whether you agree it is or it isn't. This is how it is portrayed to the public. This is what they saw on their television. Now, did any epidemiological modeler back in April of 2020 come up with a model that looked like this, which is the actual deaths through the pandemic? I think we can agree the answer is no. Okay. So, our inability to distinguish between the act of undertaking investigations for the purpose of creating a sound, peer-reviewed, scientific conclusion, we continually mistake for the practice, for the actual action. I like to say that science is the wiener in the hot dog. Scientific investigation is the abattoir that hot dog lovers are advised not to go to if they ever want to eat a hot dog again. Okay, it's messy, and the fact that say that Ferguson whole thing is portrayed to the public, of course their trust in us is going to be diminished, and I think in part that it is a semantic issue. Anyway, okay, so you can again have a quick look at this. I show you Justice Potter Stewart, late Justice Stewart, who is well known in the U.S. for having answered the question when the Supreme Court was trying to figure out, what is or isn't pornography, and his answer was, I know it when I see it, and I think that we all know science when we see it, but our inability to distinguish the active investigation from this, finished product is going to get us in trouble, or it's getting us in trouble. And okay, we need a better vocabulary when talking to the public, lest we be trusted even less. Thank you.
Okay, thank you, Mark. I also have a lot of questions, but I'm going to start with the audience. We have a bit of time to take a few questions. Who wants to go first? We'll start from here.
Yeah.
Okay, thank you very much for the talk, and it was very interesting to see that you give us a lot of evidence that there's no evidence required to become paradigm. Like the people in 30s and
Yeah, right.
60s.
So our history is a little pathological.
Yes. And my question is that my understanding about science is scientific method, or anti-scientific approach, is the pursuit of truth. So my question is, at what point that you can call the findings are objectively true?
Well, as I mentioned, and I think the second slide, that we're all sort of obliged to say, well, we can never prove anything to be absolutely true. All we can do is falsify hypothesis, even though you and I know what that beer glass is going to do if I let go of it. So I think that we're safe, always having this conditional expectation that anything we know could be proven wrong tomorrow. So let's not use the word truth. Let's not use the word belief when we're talking about trying to understand the physical world, and then we're better off.
Thanks for the talk. My question is, what's a good observational constraint then? Because I'm sure to Alessandro Morbidelli, the peak he saw was
Sure.
To his eyes, good observation.
Irresistible.
Yeah. So like, are you saying like unbiased observational constraints, or is that the key point? Like when you talk about constraints?
Yeah, of all the things I mentioned, that would be the one exception, right? That's the case where actually Alessandro, or Morbi as he likes to be called, actually, felt that there was this, clear physical evidence. But I think that the fact that it wasn't raises an even more disturbing question, because, you all may have heard of the Apollo lander missions, right? It cost, back then, $30 billion. That was a lot of money. This was a big national effort, a flagship operation. We brought these materials back, there's 700 kilos. It's not a lot. And these people were given, basically, it was actually called a license to kill, because in the 4039 analysis, we basically turned this stuff into glass. And that happened. Why? Well, all kinds of, we've talked about this, right? That you think NASA headquarters didn't like the idea that this, idea that didn't exist before the Apollo landers. That in fact, this was seen as one of the two triumphs of the Apollo missions. The fact that the moon was essentially fully melted on formation, and the late heavy bombardment. So, you want to get funding? Who's going to get funded? Hey, I want to further test the late heavy bombardment hypothesis, or I don't think this thing ever happened. Okay, so there's all kinds of this, this sense of social ordering. Has an immense funding, of course, is key to all of it.
In that sense, I feel like to put out a hypothesis like the late heavy bombardment based on some kind of observational constraints until falsified, I feel it sounds like a very, scientific thing to do.
So where did we go off the rails? We went off the rails by, in fact, finding selection criteria that have no basis in physics. I'm going to cherry pick an age off this continuum, and then I'm going to make a histogram. Okay, I mean, you know, where's the camera? That's unethical. Yeah. So, you know, that's the one. I mean, geosyncline theory, I said that all these ideas, you know, there's no bad ideas, they're all good. Geosyncline was stupid. It was stupid then, it's stupid now. Okay, so not all new ideas are interesting. But again, you know, we're saying that we're a species that demands a tribal chant. And in not understanding how mountain belts formed, this was the one little scrap that we were thrown, and everybody gobbled it up. It was the absolute dominant paradigm of that time. So, not to put too fine a point on it, but you know, we really went off the rails with the LHB.
Okay. Thank you.
Let's go back there.
Social scientist in background, research background. So you're talking about social order inside the scientific community somehow. But you can't deny there's some kind of development. We have technical development. We are able to do different things than 100 years ago. So there are some kind of things that are possible to do with some kind of scientific insights, right? So is it just needed that we avoid the word truth or anything, but still we can use these scientific insights to do different things we are not able to do in the past? Because, yeah, there is some kind of development. I don't want to use the word progress, or would you say it's just like because we changed the way how we observe the world that we just ended up with a different type of ontological insights, but it's still the same? I don't know. So, or what is the justification for science then?
Well, at the same time that, you know, my erstwhile colleagues were going off the rail with the LHB, somebody was in the basement at Yale University inventing the MRI, okay? And so, you know, as I said, there's undeniable progress. There's experimental science has a gigantic leg up on what I do because, you know, they don't need to figure out what happened 3.5 billion years ago. That's tough because we have this, let's say, fragmentary and biased record. So, you know, I'm not condemning any part of this. I'm trying to draw attention to the fact that you know, we, you know, at least in my business, we broke trust with you, with the American taxpayers that, you know, spent the $30 billion to bring those materials. 3 men died bringing those samples back, and I think that, you know, I hope I've shown you that this wasn't an isolated occurrence. This is our pathology. We've been doing it for 100 years. We're doing it now with, you know, if we don't see evidence of plate tectonics in the fragmented and biased geological record, it means it didn't happen. So I'm not at all condemning, you know, science in general. And you know, I hope with this little op-ed with the second last slide, I'm pointing out that you know, we're part of a continuum that is ineffectively communicating with the public about, you know, what we know. I mean, I'll give you some insider baseball here. That, you know, many of you know what the journal Science and Nature is. In China, there was, at least, you know, in the recent past, $30,000 bounties on getting a paper published in Science and Nature. These are weekly international journals. But the only time I've ever had a title or an abstract of a paper changed was when I published in Science and Nature. We're all part of the pathology. I want to get published in Science because, you know, my dean doesn't know what Earth and Planetary Science Letters is, but he knows what Nature is. So we're all active participants. When nature sexes up my title. Did I protest? Well, I did, but they did it anyway. Yeah, and so it's a continuum, effectively. You know, that's a commercial journal that has, you know, Springer Nature has shareholders. They want to maximize their profit. So we like to see ourselves as these, you know, objective truth-seeking scientists, but our institutions now. I get you know, emails that say, you know, let us brag about you. Okay, tell us what your discoveries are. I'm being encouraged to overstate. I mean, what I do is I make incremental contributions, and occasionally there's, you know, something remarkable, but I'm being asked to oversell it. I'm being asked to hype, and then the community's hearing, well, wait a minute, sorry, I just heard on the news that plate tectonics started 2.5 billion years ago. Didn't I just hear last week that it started 4.5 billion years ago? But, you know, we don't know. Okay, so, you know, stop doing that because we're continuously eroding confidence in the people that are paying our bills.
Yep. Okay. Well, I do agree with the main points about the importance of escaping, I would say, social group dynamics in the practice of the social institution that is science. But I think there is also an issue on the public side, which is scientific results are basically hypotheses waiting to be disproven somehow, and the consensus reality that we build through the observation that, well, those are not levitating, at least until now. But on the other side, and to come back, for example, for the COVID example, or even also climate change example, there is also a responsibility from the society and the politic as an institution to use those data wisely. For example, when we think about climate change, there is debate about trying to preserve the 1.5 degree limit, or actually realizing that it's maybe already hopeless and go to another level, or also how do you deal with the result from the GEC, which is basically a consensus on the largest common denominator, so which means that you forget all the possible low probability, high impact events that piles up, and that as a politician you have to take into account. So yes, it's important to change concept of science, but there is also a need for responsibility on the, I would say, client side from the society, I think.
Yeah, I mean, climate change is an interesting, obviously topical issue, in as much as, in my experience, in my realm, about 20 years ago, it ceased to be a question of science. In my institution, it became a political agenda. All that we can do as scientists is, our models are fallible. We can express, probabilities, and but where we, I think, went wrong is, making this, basically taking a side. That, once the Paris Accords are signed, that, us responsible scientists are necessarily for that particular political action. I think that was a giant mistake. And, it's in the U.S., it's got us where we are now, where we effectively have aligned ourselves with a fairly narrow political base. And now, in fact, funding for, it's one thing for you to, say, God, what will humanity do if we don't know when plate tectonics really started? But I think about those 20 million people who are only alive today because we retain that level of trust. So I think climate change is a great case study of how science shouldn't, in fact, be politicized. I mean, it's at my university, flag was planted, and frankly, you all come. and it ceased to become a question of, let's continually test what's going on to, oh no, we have the answer, and and you're wrong.
Belief is the death of intelligence, isn't
Sorry?
it? Belief is the death of intelligence.
Okay, I'm thinking that you guys
Yeah,
have been really well behaved, and I'll let you go.
So with that, we'll wrap up the Q&A, but Mark, you'll stay for a bit longer.
Sure, sure.
Yeah, so feel free to catch him. Thanks again, Mark, for the
Okay, good.